Welcome. We're going to start our unit with systems of equations, and one of the first things that we need to know about when we're talking about a system of equations is, well, what is a system of equations and why are we going to bother to try to solve it? So essentially, anytime we've got two things working, two things that we want to compare that we can make a mathematical equation for, we can use a system of equations to figure out when something happens. So let's just say, just total random example, that you're buying some stuff from a catalog. Okay, so it's some sort of catalog example, and one company charges you, say, $1 for shipping. Okay, and it turns out that their prices are pretty expensive, so we'll go like that. Okay, there's another company that charges you $5 for shipping, and their prices aren't as expensive as this one, so we'll just represent that with a little less steep sort of equation. So as it turns out, this gives you the total cost for items for company number one, which has a low shipping price but higher prices. This gives you the total cost for the other company that has a little higher shipping price but lower prices overall. Right here, that's where you make the switch. Up until this point right here, this company's cheaper. When we get to this place right here, this company's cheaper. So anytime we're trying to compare things, we want to find out where that break-even point is, where that place where the two curves meet, so that we can make some decisions. We have two equations. That's what we call a system of equations. First method, the one that we're going to use today, is called the matrix method. And we've been talking about matrices for the last couple of days, so we're just going to jump right into it. With these equations, 3x plus 2y equals 7 and 5x plus 3y equals 11, we're looking for a value of x and a value of y that makes both equations true. So as we're doing this, we're going to just set up some matrices, and I'm just going to show you how to do it, and then we'll show you how to solve it as we move our way through. So my first matrix, I'm going to put the coefficients, which are the numbers in front of my x and my y. So these are called coefficients. You've seen that word before. Coefficients. Next matrix, I'm going to put my variables, x and y. Okay, these are my variables. And then, in the last one, my constants are my answers. Okay, these are constants right here. Constants. If we remember matrix multiplication, we do row by column. And so if you look, 3x plus 2y equals 7. That's this equation. 5x plus 3y equals 11. That's that equation. Okay, so that's really nice and delightful, but how do we actually use that to solve and figure out what x and y are? We're gonna sort of simplify a little bit. I'm gonna call this matrix matrix A. I'm gonna call this matrix matrix X, and I'm gonna call this matrix matrix B. So if I multiply A times X, I get B. Do you remember when we talked about inverse matrices yesterday? If I multiply a matrix by its inverse, I get 1, the matrix form of 1. So on this side, I'd be just left, if I did A inverse times A, I'd just be left with X. If I multiply one side by something, I have to multiply the other side by something. So ultimately what we're going to get is my X matrix is going to be equal to A inverse matrix times B. And again, great, super swell, but how do I make that work? Well, the calculator will do a good portion of this work for us. So what we do, as we're working our way through to the calculator, we're going to enter the matrices in, and we did this yesterday, but we'll go through it again. So second matrix gets us to the matrix names. We're going to go over and we're going to edit our matrix. And so with the editing, we're going to call matrix A, this is the one we want to edit. We're going to put in matrix A, where is it? There it is. These numbers, the 3, the 2, the 5, and the 3. All right, so I go back to my calculator. I'm just going to call it a 2 by 2 matrix, 2 by 2, and I'm going to put the numbers 3, enter, 2, enter, 5, enter, 3, enter. Okay, I've got matrix A. I quit to get out of there. I go back to matrix again, and I need to edit matrix B, which is going to be my 2 by 1. It's going to be that constant matrix. It's still 2 by 1. If it wasn't, you know how to change that. You just type the numbers in. We're going to put our numbers in, 7 and 11. Those are the numbers that we're talking about here. And so now we've got matrix A and matrix B in here. To get the actual answer, we second quit back to our home screen. We just do second matrix. We want matrix A, so we call it that. We want the inverse, which is this key right here, the x to the negative 1. See it? It makes a negative 1 sort of a situation. Don't adjust your set. I just got interrupted, so we're going to start over again. So we're going to get to the matrix, second matrix. Matrix A is the one we want. Then we're going to hit the inverse button, which is that one right there. So it shows up right on our screen. We're going to do A inverse times multiplied by matrix, in this case B, which is number 2. When we do A inverse times B, we get that answer. So it turns out that this number is my x number, that number is my y number. That's the solution to the system of equations that we just dealt with. Okay, so I'm going to go to the next screen. That's the system that we started with. We put matrix A into the machine. We put matrix B into the calculator. Just to show you what A inverse is, it's just a different form of that. If I multiplied these two matrices together, I'd get that matrix form of 1, 1, 0, 0, 1. The actual screen work that we did, A inverse times B, and this tells me x. This number is y. If I check it out here, 3 times 1 plus 2 times 2 should be 7. That's good. And 5 times 1 plus 3 times 2, 3 times 2, that's what that should say. That turns out to be 11 as well. Okay, so really, this is sort of a quick, easy process. It'll work most of the time. It'll get us some information. If you happen to have a calculator, it makes it that much easier. First thing we do, another system of equations, we put our coefficients into matrix A. 5, 3, 2, and because this is negative right here, we need to make this negative 4 as we put it into our matrix, the variable matrix, and then the constant matrix. So we write those down, we go back to the calculator, we go back to the matrix piece, we go over, we edit. We've already done the work, so we know it's a 2 by 2. We pop in our new numbers, 5, enter, 3, enter, 2, enter, negative 4, enter. Make sure when you do negative you use this key right down here, the negative, not the minus sign, because the calculator will not like it. We second quit. Always that brings us back to our home screen. Then we do second matrix. Where'd it go? We go down to matrix B, and I don't know why I did that. I want to actually edit a matrix B, so we'll try that again. We go down to over to, that's the problem, matrix B. Do that. We know it's a 2 by 1. We know the numbers that we want to get in there are 25 and negative 18, again using the right key. We second quit to get out of there. And now we just need to do the setup here on the screen. I'll clear to get it out of here. Second matrix, matrix A inverse times second matrix, I'm hitting the right key, matrix B, boom. Okay, so these numbers, 1.76, 5.38. Not really as nice numbers as we had the last time, 1 and 2, but they're the answer. They're where, if we had a system, that would be the place where we change from one equation to the other, because one turns out to be lower or bigger, depending on what we're trying to actually do with the information. But that's the solution. X is 1.76, Y is 5.38. So X equals 1.76, Y equals 5.38. Put a box around it, call it done. Do one more. I think we got time to do that. Okay, just to get you into the habit, we do coefficient matrix 3, 2, 9, 6. Our variable matrix x, y equals our constants 6, negative 6. as we go. Easy enough to deal with. We just put those in, 3, 2, 9, 6. Let's go there. We go back to matrix again. Make sure that we go over to edit. Okay, and we're editing matrix 1. It's still a 2 by 2 matrix. 3, 2, 9, 6. Enter. Got those. Second quit. Second matrix. Over to edit. Down to choice number 2. And it's still a 2 by 2, 2 by 1 matrix. And I got to look back because I forgot what the numbers were, 6 and -6. So we just pop in 6 and -6. You'd have the papers written right next to you, so you wouldn't have to go to another screen. We've got it. Second quit to get out of there. Since the last thing we did was A inverse times B on the calculator, if I just push it again, it'll give me the new results for this new set of data that I've just put in there. So I'm going to just do that because I'm efficient. Uh-oh. Singular matrix. Okay, so we've got a problem with this matrix. And if you may remember that not all matrices have inverses, that's what this means, which basically means that for this system of equations right here, there is no solution. So if we get some sort of an error that tells you that it's a singular matrix, or we get an error, and we know that we've entered all the numbers incorrectly, which we have, then that tells us we have a singular matrix, which means something, and we'll talk about that the next time. Today, all we were really worried about was can we solve systems of equations using matrices? Set up the matrix, enter the data into the calculator like so, A inverse times B every single time. As long as there's an answer, you'll get it that way. Okay, so thanks for watching. Bring questions with you. If you're still not sure, we can try to work through it. Thanks for watching. Hope you figured something out.